Hello and welcome to today's presentation. Today we are going to be discussing nuclear energy in Saskatchewan from an engineer's perspective. Our group is comprised of Tessa, Caitlin, Erica, Landry, Braden, and I. Today's presentation will be going over nuclear energy in Saskatchewan, the potential issues associated with nuclear energy, as well as the impact that can occur based off nuclear energy, the cultural effects, and going through some case studies of lessons learned from previous mistakes. Is this technology new to Saskatchewan? Currently, nuclear energy is not used in Saskatchewan. However, it is being considered for the future. 15% of Canada's power comes from nuclear generation. However, this is just split up between Ontario and New Brunswick, as no other provinces have gotten involved. The figure here represents the current breakdown of energy within Saskatchewan. As you can see on the legend, blue is hydro energy sources, red is natural gas, and green is wind, purple is coal. Unfortunately, almost 80% of our energy comes from coal, gas, or other, and that leads to a lot of carbon emissions. 20% of our energy comes from hydro sources, which doesn't have a lot of carbon emissions, luckily, and 3% is from wind, which also doesn't have as much of a carbon impact as coal, gas, or other. I'll now pass it off to Caitlin to talk more about emissions and the associated energy source.
Key issue with climate change globally is the greenhouse gas emissions produced. Saskatchewan currently relies on gas and coal power generation, which emits significant levels of greenhouse gases. Nuclear energy has lower emissions than traditional energy sources. Emissions vary from 34 to 83 kilograms of CO2 per kilogram of uranium. Higher ore grades will be on the lower end of these emissions. Saskatchewan has much higher ore grades than the world average and therefore will produce quite low emissions closer to the lower end of the range of expected emissions. Above, an RCP of 4.5 indicates catastrophic climate change. This is anything more than a global temperature increase of 4 degrees Celsius by the year 2100. To keep the global temperature rise by the year 2100 at only 2 degrees Celsius, we need to switch to having low-carbon primary energy account for 40 to 60% of the world's primary energy in the next 30 years. Then, nuclear energy is seen as very unsafe by the public compared to other energy sources. Due to air pollution, primarily caused by burning of fossil fuels and biomass, it is estimated 5 million people die prematurely every year. Accidents may occur in the process of providing any energy source. This includes the mining of coal and extracting of oil and gas, as well as transporting these materials, building the facilities, and many other aspects. This bar graph shows the death rates from both air pollution and accidents per 1 terawatt hour of energy use. This is approximately the same amount of annual energy consumption of 27,000 citizens. So given a town with this many citizens, if they got all their energy from one source, 25 people would die from coal power, 18 people from oil power, 3 people from gas power. For nuclear power, it would take between 14 and 100 years before someone died. For wind, it would take 29 years before someone died. For hydropower or solar, it would take between 42 and 53 years before someone died. From this, it is clear that nuclear is far safer than what is currently being used in Saskatchewan. A common argument is for the transition to 100% renewable resources. However, this is not an option in Saskatchewan because of our lack of access to hydro and also because solar and wind are both intermittent energy sources. I will now pass it on to Braden to talk about the potential problems with nuclear energy.
The waste that comes from mining uranium, called tailings, is stored in tailings management facilities. These facilities are former open-pit mines that have had their resources depleted. In Saskatchewan, we use the Key Lake and Rabbit Lake mines for this purpose. These tailings are classified as low-level radioactive waste, meaning that they lose most or all of their radioactivity after about 300 years. The spent fuel rods are stored in pools submerged in 20 feet of water, which is more than enough to block all radiation from reaching the surface. The water needs to be constantly circulating because the rods are still very hot and dangerous. After the rods have cooled sufficiently, they can be moved to dry storage to free up more space in the pools. The pools and dry casks are typically held on the site of the nuclear reactor. Decisions have yet to be made on what the long-term storage will look like. We need something that will be reliable for hundreds of thousands of years. One option is deep geological storage, where the spent fuel is deposited several hundred meters beneath the surface of the Earth. Northern Saskatchewan would be an ideal place for this, as the Canadian Shield here is very tectonically stable. The concrete pad shown in these images is 70 meters long and 20 meters wide. The pad has the same area as a CFL field from the goal line to the 23-yard line. The cylinders shown here are dry casks that are storing all the waste after 28 years of continuous operation of a decommissioned 619 megawatt nuclear reactor in Connecticut. Based on 2016 numbers for population and energy usage, the waste in this picture represents enough generated electricity to power Saskatchewan for 5.5 years. The table on the left in this slide shows the amount of radiation that a person living in the evacuation zone of the three most well-known nuclear accidents would expect to receive over a 70-year lifetime. Comparing this information to the table on the right, it is clear that there are much more common radiation sources that are comparable or even exceed the radiation dose from these three disasters. I'll now pass it off to Erica to talk about some of the impacts of adopting nuclear technology.
An immediate impact that comes with building nuclear power plants is the high initial capital cost. This initial capital cost can be anywhere between $6 to $9 billion. On the positive side, once the nuclear power plant is built, this will create job opportunities in the community. For every 1,000 megawatt of capacity, 500 jobs are created, which is significantly higher compared to other energy plants. Overall, nuclear energy is a very efficient way to make power with economic advantages that can benefit a community and an entire province. A potential delayed impact that comes with nuclear energy is safety. Safety must be held at a high standard, otherwise dangerous events can occur and impact communities severely. A solution to improve safety is innovation. Through innovation, nuclear energy can be made more safe and nuclear waste can be minimized or used for other applications. Currently, Bill Gates, founder of TerraPower, is working on a traveling wave reactor, which places a small core of enriched fuel in the center of a large mass of depleted uranium. The major benefit of these reactors is high fuel utilization that does not require nuclear processing and can eventually eliminate the need to enrich uranium. The possibility of a nuclear disaster cannot be ignored from past events like 3 Mile Island in 1978, Chernobyl in 1986, and Japan in 2011. Due to these events, only 28% of people found in favor of nuclear energy in a survey conducted by Furitation. If innovation and safety are continuously improving, this negative social impact will minimize, while a positive social impact will increase. Nuclear power plants supply stable career opportunities because the life cycle of these plants is 40 to 60 years. If there are steady jobs, this will lead to a happy and stable community. A single nuclear power plant creates an average of 20 metric tons of waste per year, which will need to be stored in a designated area. This may cause a negative physical impact if the environment, safety, and wildlife are not held at high standards. On a positive note, nuclear energy comes with zero greenhouse gas emissions. The reason why we want to eliminate greenhouse gas emissions is because these gases block infrared radiation from leaving the Earth's atmosphere, causing global warming. Nuclear energy would have a major positive physical impact because it would reduce the rate of global warming. Now I'll pass it off to Landry to talk about nuclear energy's influence on cultural development.
As Erica discussed, it is hard to imagine a future which doesn't rely on nuclear energy, but we are not there yet. Adoption of the technology will require a cultural shift around how we think about energy production. We need to take an objective outlook on the costs and benefits that different types of energy offer society. This means not writing off nuclear due to the way some media outlets portray it. Engineers will play an important role in this, working at institutions which will educate the public on the issue, and also in developing the technology which will one day be implemented. Once adopted, nuclear energy offers two main benefits to Saskatchewan's cultural development, by first supporting the local economy, and second, providing northern energy independence. By transitioning to nuclear energy, we will be supporting the local economy through our uranium mining industry, and by reducing our reliance on power importing. Saskatchewan is a global leader in uranium production, producing 13% of global uranium ore in 2018. In 2017, the industry provided $331 million in direct salaries, $98.8 million in contractor salaries, paid $94.5 million in provincial royalties and taxes, and purchased $402.7 million in goods and services. The uranium industry has been in a slump due to poor demand since the Fukushima nuclear disaster in 2011, but it is reasonable to assume that the economic benefit to the province will exceed 2017 values with better market conditions and increased local demand. In the future, Saskatchewan plans to increase power imports from neighboring grids to meet the increasing demand while also meeting environmental targets. We are doing this as it is difficult to meet environmental emission targets while running conventional fossil fuel power plants. Nuclear power provides an alternative, having low emissions and being capable of base power generation. By investing in nuclear infrastructure now, we will reduce our future dependence on external grids and have the potential to be a power exporter. Northern Saskatchewan communities currently have power supplied by an isolated northern grid, which experiences frequent and prolonged outages. Diesel generators are used as backup, though diesel is expensive and supply is limited at times. Poor reliability of electricity is associated with stunted economic growth of the communities and a risk to safety due to unreliable heating during cold winter temperatures. Implementation of SMRs, small modular reactors, have the potential to solve this problem by providing reliable off-grid power to these communities. SMR tech could also expedite the establishment of more northern communities. One drawback is that SMR technology requires a large initial investment. I'll now pass it off to Tessa to discuss a few case studies.
The two case studies we are going to focus on today are the events of 3 Mile Island and Fukushima. As discussed in class, a malfunction in the secondary cooling circuit at the 3 Mile Island nuclear generating system caused the temperature in the primary coolant to rise. A relief valve then opened but did not close, although instrumentation showed the valve being closed. Eventually, operators were able to achieve forced cooling, but not without radioactive gases being leaked to the environment. So what can we learn from this scenario? Not only was the instrumentation faulty, but the training programs inadequate, altering the operator's ability to act and respond. Communication was also a huge issue. Conflicting information was made available to the public, creating public fear. As engineers, I think it's important to realize that you can't design for every possible scenario, but we should learn from every failure. Regardless of these events, in 1991, the 3 Mile Island Cleanup Program was named by the National Society of Professional Engineers as one of the top engineering achievements in the U.S. On March 11, 2011, an earthquake of magnitude 9.0 hit Japan, triggering a 15-meter tsunami. At the Fukushima nuclear power plant, the entire site was flooded, and the ability to maintain proper reactor cooling and water circulation function was gone. Due to this, many weeks were dedicated to restoring heat removal and dealing with the overheated spent fuel rods. The question is, could this have been prevented? The original design saw the plant being built 10 meters above sea level, along with seawater pumps, but in 2002, the design was revised to 5.7 meters above sea level, and the seawater pumps were sealed. Therefore, when the 15-meter tsunami hit, the turbine halls were under 5 meters of seawater until levels subsided. Japan is located in one of the most seismic areas in the world, so shouldn't they have designed for this? In the last century, there have been 8 tsunamis in the region. 18 years before the incident, information was made available indicating this exact situation, but the plant operators nor government regulators took action. As well, simple design features were lacking, such as moving the backup generators uphill, sealing the lower part of the buildings, and having backups for the seawater pumps. In summary, we've discussed nuclear energy as it pertains to Saskatchewan, the potential issues that could arise from nuclear power and its various impacts. We also touched on nuclear energy's influence on cultural development and reviewed a few case studies. We hope you enjoyed listening and stay safe.